sense. So this is where we can actually build a bigger neural network. So if you go through like section 44 and section 45, they talk about, I think it's actually a direct picture here, is that they kind of talk about like these different inputs. So these can all be different numbers, for example, location. You can think of that either being like, it's in this city or not. So it can be one hot encoded, or it could be, maybe even like, I don't know, like how far west you are from a certain spot, the pricing, and the variety and offering. So these are different inputs you have. And then our outputs would be sales. And then we would have like these extra layers in here. So you can think of each one of these little nodes here as a separate perceptron, right? And we're basically just connecting them all together. Okay. And then this input part right here, you can think of it as being like a bunch of latent features. So you can think of like location, pricing, and offering. So you can see they all have arrows pointing to this one part. You can say, based on these things, we could predict the number of people that will walk by, right? And that will translate into how many sales there are, right? There's a certain factor of people who, if you have more people who walk by, maybe there'll be more sales kind of deal. And the idea here is that the neural network is trying to figure this out the best way. And you can see something similar where location, pricing, variety, and offering will combine together to talk about affordability, okay? So one way you can think about this, again, is just like the neural network is trying to find ways to take the inputs and create some latent features that will predict the output, okay? But another way you can think about this, which is much more mathematical, is you can think of this more like linear separators. So one thing you can kind of look at right here is, I'm going to do a little quick plot. And if you imagine, before I label these parts, if I wanted to say, okay, all of these ones in yellow right here, I can imagine drawing a line straight through here. And we know how we can make a two-dimensional line, right? It's just feature 1 times the weight plus feature 2 times weight minus or plus, some other thing equals 0, and that will grade our line. So it turns out that we can actually use that exact same thing. It's like, hey, well, we already have that in the perceptron, right? Our perceptron is literally exactly that. This x1, w1 plus x2, w2 plus x3, w3. If we just set this equal to the bias, so just one number, and set this equal to 0, now we have a line. We can actually create these linear separators and stuff like this. So what's kind of cool is we can actually think of each of these perceptrons kind of going forward into this part is basically a different way to make a linear separator. So you can kind of imagine, if I were to draw on top of this, imagine this is 2 dimensions. So I know it's technically 3, but we're just gonna ignore that part. Is that if you imagine like our different dots, you can say, okay, this is the linear separator here. Maybe this one combines together to make a separator like this. And this one has a combined together to make a separator that looks maybe more like, I don't know, like this. Okay. And so each one of these will probably by itself won't, do a great job predicting a very complicated system, but you can then combine them together, because what happens on this guy right here, these each will have their own weights. And so you can say how much of this weight you kind of put together. So how do we combine these linear separators into something and make something that's more complicated, basically something that's not linear anymore. So that's kind of one way you can think of it as well. And that's what I'll tend to gravitate towards, because that's kind of like how we'll approach things when we start looking at neural networks. Okay. And so if you see this right here, this is again from the curriculum, this is kind of like the more mathematical way of kind of considering something like this. In this case, we only have 2 inputs. We have our W1, you can think of these combined together to create the Z. And then we have our activation function in the middle here that's going to make it into a nonlinear. Note that the sigma stands for basically doing a sigmoid transformation or a logistic transformation. And then we can say this L right here. Does anyone know what this L stands for by chance?
Yes, backpropagation.
Say again?
Is it backpropagation?
Not backpropagation. Backpropagation will actually be the algorithm that will do this. But this L here will help us with backpropagation. This is the loss function. So saying basically how far off we are from our prediction. So y hat is our prediction, y being the actual true measurement, and that's going to give us our how different we are from the true value. And then what we'll do for backpropagation, we'll actually propagate that error backwards through the thing and adjust our values. Okay. So anyway, cool. I want to make sure I had enough time and everything so we can actually try things out too. So essentially, I like to say, like, if you can think of neural networks like this, this will make it a lot easier to like understand like why we're modifying things. But you can also like think about neural networks being like, oh, it's trying to find these other latent features, you know, like combine these different inputs and creating these different latent features that kind of create, you know, a prediction for the sales part. This will actually be really important as you do like NLP and like word embeddings and stuff, because essentially that's what's going to happen here. But I would also say, like, if you can think of it as being each of these nodes right here are essentially different linear separators. And then what we're going to do, we're going to combine those linear separators to make a more complicated divider instead of just like a straight line. Okay, cool. Any questions so far on the thing I go through? It's a lot to wrap your mind around, I'll be honest. So if you're feeling a little shaky right now, it's totally okay. All right. So it kind of helps a little bit to say like what parts of the neural network there are, right? So the basic parts here are going to be, we already talked about one perceptron, but now we actually have, you know, this whole thing, and this can get very wide, very complicated. So the first thing we have are our layers. And so our layers here, you can think of each of this part right here as one layer, okay? And then this would be another layer here, and then we'd have our last layer here. So we actually can break this up into our input layers, which are these guys, the things that we're feeding the neural network in. And then we can talk about our hidden layers, which are things that we don't directly feed anything to, right? It's kind of like in the sense that we're putting in inputs, something's going to happen with the weights, and then as it moves forward, things are going to happen here. So we don't directly control this part. So we call them hidden layers. And note that you can have multiple hidden layers, right? Right here we only have one, but if you had like another layer on top of that, you can have more nodes now that are connecting from these previous hidden layers. So you can kind of imagine like it getting deeper and deeper in the sense of like, you know, what kind of complicated stuff are they looking for? And then our last layer is our output layer. And so our output layer basically is going to tell us, you know, what is the thing that we have. Note that if you're doing regression, your output layer is just going to be just one node, essentially, just a single number. But if you had classification, your output layer is going to be the same size as whatever your different classes are. So if you have 10 classes, your output layer is going to have 10 different nodes, because basically it's going to say, is it this node? Is it this class, this class, this class, this class, or this class? Okay. So that's what our layers. Our next part is our weights. So we kind of mentioned a little bit is that the weights are from our inputs. So every time you see these arrows, like I like to show it right here, just like in graph theory, we can basically put specific numbers on of these arrows, and each of those arrows then represents some kind of weight that's being added or being multiplied by whatever previous node it is. So if you see a node here, you take the node, whatever value, whatever number it is, and multiply it by the weight that's on this edge, and then you put it over to the next node. Okay, so we can think of our weights kind of being like how important this node is to calculate this part. So if you imagine if your weight's very, very high, right, that means like, hey, this thing's really important, you know, like definitely keep this in here. Versus if it's like close to zero, you're saying, hey, like it's not that important, you know, it's kind of start vanishing away. If you set this to zero, basically this input doesn't matter anymore. I don't care what this input is. If it's zero, it's like, if it's 100, if it's a million, if it's 10,000, you know, it's negative 10,000, right? It won't matter because the weight here is zero. So again, that's the way we kind of define of saying how important is it. Okay, cool. And then going from like these inputs to this part, this also represents a weight. And the way I like to think of these weights here is again saying like, you know, how much of these kind of like latent features are kind of contributing to like another output. But you can also think of it as like, if this is like linear combination, this is going to create, you know, this like x1 times w1, x2 times w2, x3 times w3 combined into here is going to create a linear combination. And that linear combination is just going to be a linear separator. So you can think of like this weight here saying how much of that linear separator should we include to make something more complicated. So you can also think of it like that for like the hidden layers. Okay. Cool. And then our last part here, which we kind of mentioned a little bit, but we haven't really talked about, is activation functions.